Welcome to Tech Talk. Our DevOps edition today is focused on monitoring and troubleshooting Kubernetes-based deployments. Tech Talks is a series of short webinars that are deep dives for technical practitioners. We value you, our customers, and want to continue in your Splunk journey. We created these best practices, and we want you to leverage them in your daily role. My name is Amit Sharma. I do product marketing at Splunk, and I'm focused on infrastructure monitoring. Prior to Splunk, I was part of SignalFX team. Again, SignalFX was a real-time cloud monitoring solution that Splunk acquired in 2019. Before SignalFX, I was at AppDynamics. So I've been in this monitoring and observability space for quite some time now, but the majority of my career has been in software engineering and application development. I'm delighted that my colleague Robert Castley is joining us today. Robert?
Thank you, Amit. Hi, my name is Robert Castley. I'm a staff sales engineer for EMEA here at Splunk. And just like Amit, I came across with the SignalFX acquisition back in 2019. Previous to being at SignalFX, I spent nearly 11 years in the synthetic load testing and mobile monitoring space. And it's my pleasure to be with you today.
Okay, perfect. So today we are going to talk about what are the common challenges in monitoring Kubernetes-based applications and why traditional approaches to monitoring no longer work. We will introduce Kubernetes Navigator and talk about Splunk Connect for Kubernetes. We'll spend most of today's time in the demo. Our team will be available for Q&A throughout over the Q&A widget within your screen. And if you watch a recorded version of this webinar, please continue the conversation through the Tech Talk discussions in the Splunk community. Let's get started. Okay, so why Kubernetes monitoring is challenging? So you are here so you know that Kubernetes has become the de facto standard for container orchestration. CNCF does these surveys every KubeCon, and what they found out is monitoring is one of the biggest challenge in Kubernetes adoption, right after complexity. And monitoring becomes even bigger challenge for the companies that are at a scale, right? So 48% of respondents are saying that monitoring is the biggest challenge in their Kubernetes adoption. Why is that? Well, first off, to start with, there are just more components. Kubernetes is a distributed architecture, distributed solutions. There are many more components to monitor, and traditional approaches do not address the multidimensionality and the correlations of all these components from which the data is coming. Second, the containers pods are ephemeral. They are dynamic. They can come and go. So traditional tools, again, cannot address the dimensionality, the dynamism of these components. There are multiple data sources, metrics, events, logs. They are, in traditional approaches, they are siloed. DevOps and SRE teams will have to continuously switch context between metrics tool to a logging tool. That leads to higher mean time to resolution. And then there is lack of automation. Data is coming in from multiple components at a high speed. Correlating information from all these sources manually is just not going to work. Traditional tools, again, do not leverage the machine learning or AI capabilities to make sense of all this data. So a new approach is needed to monitor Kubernetes-based applications. First, we need the understanding of the health of entire Kubernetes cluster and the interdependencies of different components that make up Kubernetes cluster, nodes, containers, workloads, and Kubernetes components. Then we need granular logging within context. So wherever we are in monitoring Kubernetes component, we don't have to switch context when we are pivoting to logs. And everything is coming at real time. So analytics and insights will have to be streaming and alerting has to be in real time. And finally, we leverage AI and ML-based automation. So with that, let's talk about Kubernetes Navigator. Kubernetes Navigator provides real-time monitoring and observability for containerized applications. Now, it is not a separate product. It is included in Splunk infrastructure monitoring. So let's start with installation and deployment. It is one-step Helm installation. It is node-based daemon set. It is 100% open source smart agent. It automatically collects all the Kubernetes components and also discovers applications deployed such as Nginx, Cassandra, MongoDB, Redis, and many more. Once it collects the data, it provides curated, pre-built, out-of-the-box dashboard. So you can instantly monitor your services and reduce time to value. So dynamic cluster map. So you can start with the bird's eye view and understand the health and interdependencies of the entire Kubernetes environment. Now I'm going to go through these slides pretty quickly because you're going to see them in action, these features in action in the demo. A global at-a-glance view into the entire Kubernetes environment helps teams understand how the overall system is performing. It is equally important to have a granular, detailed view into individual components, as we are narrowing down the source of the problem, drilling down from nodes to pods to containers to workloads. Now, one thing that we have in Splunk infrastructure monitoring is streaming architecture that enables in-depth analysis with search and filters. If you have thousands of pods, you can get to the individual pod within seconds. So we can do this at a massive scale. From wherever you are in your monitoring workflow, seamlessly pivot to logs and get granular visibility into application, Kubernetes, and container logs to correlate performance across the entire stack without any context switching. Visibility into lifecycle events of Kubernetes and API server audit logs help you understand and maintain your security and compliance posture. To understand the why behind performance anomalies, Kubernetes Navigator leverages AI-driven analytics, which automatically surfaces insights and recommendations to precisely answer in real time what is causing those anomalies across the entire Kubernetes cluster. Again, wherever the problem may be happening, nodes, pods, containers, or workloads. Let's talk about Splunk Connect for Kubernetes. It provides a way to import and search Kubernetes logs and object data within Splunk. It uses Kubernetes node logging agent to collect logs. It is deployed as a daemon set on each node in the cluster. Now, each daemon set holds a Fluentd container to collect and transform the data. It's a comprehensive log collector. It collects Kubernetes events and logs as well as application logs. It reads from systemd journal if it is available on the node, and it tails logs from the file system. We use JQ to transform the raw events into Splunk format. For Kubernetes, Kubernetes API server sends new changes to the plugin in watch mode, so only the changed data is collected. In the pull mode, the plugin queries the Kubernetes API server, so all the data is collected. Once the data is collected and transformed, it is sent to Splunk Enterprise or Splunk Cloud, whatever deployment that you have, via the HTTP event collector. So let's switch over to demo and see all these features, all these capabilities that we talked about in action. Now we're going to walk through Splunk infrastructure monitoring and demonstrate real-time problem detection and root cause analysis. We will have deep linking from Splunk infrastructure monitoring into your Splunk environment. So Robert, take it away.
Splunk infrastructure monitoring provides DevOps, CloudOps, and SRE teams with real-time, full-stack visibility across all layers of their environment. With hundreds of out-of-the-box integrations, streaming analytics, pre-built-in dashboards, intelligent problem detection, programmability, and service bureau capabilities, Splunk infrastructure monitoring provides the fastest, most accurate, and most flexible visualization and alerting for enterprise DevOps teams to meet or exceed service level objectives by quickly detecting, triaging, and resolving performance issues. Splunk infrastructure monitoring easily and swiftly integrates with all three major cloud providers to give you an overview of each of those providers. The integrations take only a few minutes to get up and running, and we will then start streaming the data in from your cloud providers, giving you a single pane of glass view for multi-cloud environments. We also provide a smart agent technology that you can install on host instances or VMs to start streaming in those host metrics. And the smart agent has the ability to auto-discover other services that might be running within that environment. So if a host is running Docker, it will detect it's a Docker host, build out the dashboards automatically, and also if it discovers any services running within that environment, it will also build out the dashboards for that given service. Combine that with the ability to also monitor your serverless functions, whether that is streaming in the metrics directly from your cloud provider or using one of the Splunk provided wrappers where you can then instrument your functions to expose the metrics and any custom metrics. You will get a complete visibility into your serverless environments as well. The Kubernetes Navigator has been designed to provide you with comprehensive insights into how your Kubernetes cluster is behaving. Now, in this particular environment, I have a number of Kubernetes clusters available to me, but I'm only interested in one today, and that is my own personal cluster that I have running here. When I drill into my cluster, I can hover over the cluster and get information in and around my cluster. So this is a 12 node cluster. If I hover over a node, it will tell me how many pods I will have in that node. I can also visually see that by the squares that are displayed within that node square. And when I hover over one of the pods, it will also tell me how many containers I have running and what the pod phase is. Now, in order to show you the power of the Kubernetes Navigator, I'm going to go ahead and in the background here, I'm going to deploy a new container that is purposely going to create a little bit of havoc within my cluster environment. So I have started that deployment. It's going to deploy a brand new container into this environment, and we will be able to see this once that container is built out, see it in real time within the UI itself. Like I said, this container is designed to cause problems and wreak havoc within the cluster, and once it gets deployed into the cluster, we will see the dashboards here begin to change color, and we can then go ahead and troubleshoot. And we can see there that the deployment has happened. We have seen extra containers, pods appear, and we can also see that the health of the cluster is now reporting issues in and around memory pressure. When we move through the tabs within the Kubernetes Navigator, we can drill down and see things at individual levels. So when we come into the node level here, we can see the CPU, memory disk, network, host cores, total memory, condition, etc. of each of the nodes. And we can see there are a number of nodes there that are being impacted with memory pressure issues. We can go ahead and click the Workloads tab, and we can see here what are the services or workloads we have running within our cluster. And we can see here we have a very small e-commerce application actually running within this cluster. So we can see things like the payment workload, the checkout workload, the catalog workload, for example. We can then choose to drill down into node detail. So we can see here on this particular dashboard here, we can see there is an alarming increase here in the percentage of memory being used by pod. And I can use the table down here and look at the details of those metrics. So I can see here and sort that I have on a couple of my nodes, I have some pods running that are using a considerable amount of memory. So if I choose one of those, let's choose this one here, Robot 6, I can go and look at that in a lot more detail. So I can come over to here and put this full screen and see the metrics for this particular container. And without having to even drop down to the command line and use kubectl commands, we can see the container properties. And when I look through the container properties, I can see that this particular container has been deployed with no upper memory limit configured. And that has allowed it to go rogue on my cluster and thus causing these issues that we're seeing highlighted within the Kubernetes Navigator here today. Now, if I go ahead and roll back that bad deployment that I did on purpose, so I can do that rollback in the background, we'll be able to jump in to these charts and we'll be able to see the health of the pods return back to normal once the container has been destroyed, and we will see the charts and graphs and everything return back to normal. So this is a very short introduction to the Kubernetes Navigator, but hopefully it shows you how easy and how much detail you can get using the Kubernetes Navigator, and by deploying the smart agent that I mentioned earlier into your Kubernetes environment, you will get metrics at a 10-second resolution by default, giving you complete insight into your environment. And as I close out, you can see here that the memory levels have indeed returned back to normal since I have rolled back that particular deployment. Alerting in the platform is as simple as going to a chart and creating what we call a new detector. Detectors can contain multiple alert rules. By default, the modal window loads up with an historical time series on the left and a more detailed view on the right. You can configure the historical time series to be whatever you want. So if you had an issue, for example 3 weeks ago, you could go back to that time period and create your detector based off those metrics from 3 weeks ago. I'm just going to focus on the last 12 hours. So I have my historical window here of 12 hours, and I can use the detail view to slide the slider over to get more granular resolution of that particular time frame. Once you've got your alert signal configured, you can go ahead and configure your alert condition. And we provide a number of alert conditions out of the box. We have static threshold for is it above, is it below, was it above for a certain period of time or duration. We have a heartbeat check just to make sure that the endpoint is reporting. We have resource running out, where we look at the historical trend of the data and predict that, for example, you're going to run out of disk space in the next 24 hours. We have outlier detection for inconsistent behavior. We have sudden change. This is really useful for like software deployments, like we do a deployment and the error rate shoots up. That is a sudden change. Because we hold the data for 13 months, you can use historical anomalies for like seasonal patterns or cyclical patterns. A good example is Black Friday, where systems will be under more duress than they normally are throughout the rest of the year, but it doesn't necessarily mean you should be firing alerts just because things are being strained that little bit harder due to the influx of customers during that sale period. And then we have custom threshold. This allows you to compound conditions using and/or operators. So instead of, for example, having one detector for CPU, one detector for memory, and one detector for disk, you can compound those together and say, alert me when CPU is above 96% and memory is at 94% utilization and disk space is at 10% capacity. I have a resource issue, I need to be alerted about it. Custom thresholds are very, very powerful. Once you've chosen your condition, you can go ahead and configure your thresholds. So here I can use the detail slider on the right hand side to gauge what are my metrics looking like. So I can see here it just about goes north of 4,000. But for the purposes of this, I'm just going to punch in a slightly lower number. And what will happen in the UI is that we actually start what we call a pre-flight check, where we're going to estimate the number of alerts that would fire in a 12-hour period based upon the historical time series. And we can see there that by punching in 400, there is going to be potentially an estimated nearly 31,000 alerts being fired. That is one big alert storm that is going to cause major alert fatigue. However, if we go ahead and punch in a more sensible value based upon what we saw in the detailed view, we can run that pre-flight check again and we can see how the alert is going to behave now, estimating that within the 12-hour period, it might generate 89 alerts, for example. You can continue to tune this until you get to a point where you're happy with the number of alerts that will potentially be generated. Once you're happy with that, you can then go ahead and set the severity of the alert, add in any custom runbook URLs, any quick tips that would help the recipient of the alert be able to triage and troubleshoot the issue much quicker. And then you can define where that alert is going to go. And we provide a number of integrations with services like Slack, Teams, Jira, Splunk on Call, and we even have the ability to create your own custom webhooks, so you can fire alerts into workflow engines, for example, which might trigger auto remediation. Back to you, Amit.
All right, thank you, Robert. So now I want to show you a couple of troubleshooting workflows, right? So monitoring to troubleshooting from within Kubernetes Navigator to logs in Splunk. So here I have set up a 6-node Kubernetes cluster, and this is actually running in GKE. So I'm looking at just visually all these nodes appear, everything appears seem to be fine. So let's double click on this particular node. So again, these are pods and these are containers. So just visually inspecting this, all these pods and containers appear to be working fine. This particular pod though, right, it has seemed to be having an issue, right? Let's see what the issue is. So it looks like the container status is not running, right? Not ready. So let's take a look at what is going on with this pod. So in this menu, we will go to the pod name and click on these 3 dots. As soon as I click, I get to this menu item, examining in Splunk. So it is going to put me in logs. As I pivot to logs, notice that I did not have to write any SPL. The object that I was monitoring, I was looking at, that context carried when I go to Splunk. So I don't have to drill down, I don't have to search for it. So let's take a look at this logs that is coming on from that particular pod. And right away we see this, that back off restarting failed container. So container is trying to start and there's some process crashing in the application, which then causes the container or pod to be in crash back looped off status. And that happens when some process crashes in the application. So let's take a look at what is running in this, right? So this is email service running in my cluster. So let's go and check it out, right? In the workloads, I'm going to see the email service. And again, we will go to the application logs in this case, examining Splunk. And as we are pivoting to the logs from the applications that we are getting, again, notice that I don't have to search for it. That is coming through the deep linking from Kubernetes Navigator and Splunk infrastructure monitoring to Splunk logs. So here, let's take a look at this error message. And boom, just in a couple of clicks, we can get to the line of code level details, right? So I am trying to start a container with a Python application, which is a Python 2.7 runtime. And I'm trying to give a parameter, which is for Python.3. So this logger is trying to instantiate and it is getting an error. Right, we can take a picture of this, screenshot this, and send it to developer. Hey, on line 54, you're trying to get to a logger, and then this is the error that you're getting, and that is why the container or pod is not starting. So we just saw that within 2 clicks, we can get to the root cause and start troubleshooting and fixing the root cause. Now, I want to show you, right, one more thing here. Here I'm starting a cron job. I'm calling it hungry job. Right? Cron job is the bad job in Kubernetes, and what I'm doing here is I'm requesting like 50 core of resources, 50 core CPU for this particular workload, or 32 gigs of memory for this workload. There is no way that I have so many CPUs and 32 gigs of memory on my cluster. So let's see what happens. So when we run this, try to run this pod, Kubernetes can schedule this, right? And when it tries to schedule, it will fail because it does not have the resources. So let's take a look, right? This is happening in my Kubernetes cluster. And let's see if our Kubernetes analyzer picks it up and gives me some information where to start troubleshooting and triaging this problem. Kubernetes analyzer again is looking across the Kubernetes clusters, right? Here I have one cluster with 6 nodes, and it is looking at all the workloads that are deployed, all the pods, all the containers, and it is surfacing up by itself the potential root causes of anomalies. So it found out automatically, right? I didn't have to search for it. I didn't get an alert for it. It tells me that I didn't have to put any alert for it. It automatically tells me that, hey, there's a cron job, and this is the name of that job. It is getting into pending status. So you may want to start taking a look at what is going on here. So we can go and check out here that the error that we are getting from the cron job. So let's see, hungry, if I can type. And we get the logs from the metadata logs from that particular pod, right? Just looking at this, right? Just the logs are telling me that I have 6 nodes available in my cluster, but I do not have sufficient CPU to schedule that pod. So Kubernetes will fail every single time when it tries to schedule this. So as you can see, Kubernetes Navigator within Splunk Infrastructure Monitoring automatically picks it up and gives us a directed troubleshooting, directed way to start our triaging and troubleshooting. Let's get back to slides.
Okay, so we are about ready to wrap up this tech talk, but before we do, I wanted to share quick resources available to you to continue your journey. You will receive these assets in a follow-up email, as well as the recording of this webinar. Let me just briefly walk through each resource. The first one is a webinar that we did with Google Cloud, talking about GKE and how to monitor applications in GKE environment with the Splunk Infrastructure Monitoring and Splunk Cloud. So that's very similar to what we did today. The second one is documentation. How do you get started with Kubernetes Navigator and deploy the daemon set, Smart Agent? The third one is blogs, a couple of blogs that I wrote earlier. Kubernetes Navigator, a little bit more details on the features and installation. And monitoring Kubernetes control plane. That is, if you have your on-prem Kubernetes deployment, if you are managing, it's not a managed service like AWS, EKS, or GKE, then Splunk Infrastructure Monitoring provides out-of-the-box monitoring for the Kubernetes control plane. So some details there. Conf sessions, we have a DevOps track. So take a look at, listen to the conf sessions. And finally, we created a workshop for Kubernetes monitoring. That is step-by-step hands-on workshop. So you can take advantage of that resource. It will show you how to configure your Splunk indexes and HTTP event collector, how many index to create. Again, step-by-step, you can use that. This workshop was created for Amazon EKS environment. So that is not important here. You can use your whatever Kubernetes deployment that you have, but it will give you step-by-step instructions to start on your Kubernetes journey. And finally, don't forget that we have an incredible community of Splunk users on our community site. You can search the answer section on everything Kubernetes. You can continue the conversation for this talk within the discussion section called Tech Talks. And finally, there is Splunk Ideas. The Splunk Ideas is where you can submit new product enhancements or vote for current ideas from other customers. We really appreciate you taking the time out of your schedule to join us today. Please tune back in for future Tech Talks. We are excited to share the series with you.